In this question, we are looking for the number of moles that are in 5 milligrams. So that's the unit that we write down. So moles. And now the first question is, do we have the unit moles somewhere in our units? That's here. So we write it so that the mole is on top of the line. We have mole and 550 grams. Now we've got the moles, but the grams we want to get rid of. So do we have another thing where there's grams in our givens? Yes, that's in the 5 milligrams. So we have 5 times 10 to the minus 3. That's the milli, that's the minus 3 grams. And we see that the grams cancel out. And we are left with 5 times 10 to the minus 3 moles divided by 550. And if we put that into the calculator, we get roughly 9.1 times 10 to the minus 6 moles. Now in this question we are looking for how many grams. So we are looking for the unit grams, and we write that down. So do we have grams anywhere in our givens? Yes, we have 180 grams per mole. So we write it so that the grams are on top of the line. So we have 180 grams per mole. And so the grams are okay, but we want to get rid of the moles. So do we have moles anywhere? Yes, we have 1.8 millimole. So we write that down, 1.8, and I probably should, in this case, should say times 10 to the minus 3 mole, because we want to have the same units, so the moles cancel out. And what we have got left is 180 grams times 1.8 times 10 to the minus 3. If we put that in the calculator, we get 0.324, and the unit was this one, grams. Now in this question we are looking for the number of atoms, and we know from the Avogadro number that there are 6.022 times 10 to the 23 atoms per mole of a substance. So we are looking for atoms. Now, do we have anywhere the unit atoms? Yes, of course, that is in the Avogadro number. So we write it that the atoms is on top of the line. So we have 6.022 times 10 to the 23 atoms per mole. Now the atoms is okay. We want to get rid of the mole now. So do we have any moles anywhere? Yes. We have mole here, so we write it so that the mole unit is on top of the line. So we have mole divided by 210 grams. Now we see the moles cancel out. We have the grams left. Now we want to get rid of the grams. Do we have anything with grams? Yes, we've got grams here. So we put it so that the unit cancel out. So we have 0.21 grams. And what we see is that the grams cancel out. And we have 6.022 times 10 to the 23 times 0.21 divided by 210. And if we put that in the calculator, we get 6.022 times 10 to the 20 atoms. In this question, again, we are looking for grams. So we write down the unit, grams. And first question is, do we have grams anywhere? Yes, it is hidden here in this kilodalton, because this means 66 kilodalton means a molecular mass of 66,000 gram per mole. And what we see is that we have the unit gram in here. So we write this on our fraction here. So we have 66,000 gram per mole. Now the gram is okay, but we want to get rid of the mole. Do we have the unit mole anywhere? Yes, it is in this 1 millimolar, because this can also be written as 1 times 10 to the minus 3 mole per liter. So we write this down, 1 times 10 to the minus 3 mole per liter. We see the moles cancels out, so we now have to get rid of the liter, and we have the unit liter in here. So we have 2 times 10 to the minus 3 liter, and all our units cancel out, and we just have grams left. So what we have left is 66,000 gram times 1 times 10 to the minus 3 times 2 times 10 to the minus 3. And if we put this in the calculator, we get 0.132, and the unit is grams. In this question, we are looking for how many grams are in this protein solution of 10 milliliter of a 0.1% weight per volume solution. Now, first of all, let's remember, what does 0.1% actually means? 1% weight per volume solution means we have 1 gram of compound in 100 milliliter of usually water or solvent. So if we have a 0.1% solution, 0.1% solution, weight per volume, it means that we have 0.1 gram per 100 milliliter. And if we only have 10 milliliter, it means that this contains only 1/10 of this one here. So we would have 0.01 gram in 10 milliliter. Please note that in this calculation, these 50 kilodalton did not really go into the calculation. It was sort of a red herring to see whether you notice that we don't need this in this case. This is a very typical question for lab work. So we have a molecular mass, and we are looking for the amount of grams that we need to make up a solution with a certain concentration. So the unit that we are looking for is grams. Now, do we have the unit grams anywhere in our givens? Yes, we have 250 grams per mole, so we write that so that the grams are on top of the fraction line. We have 250 gram per mole. Now, the grams is good, that's what we want, but we want to get rid of the mole. Do we have moles anywhere? Yes, because we can write this as 2 times 10 to the minus 3 mole per liter. So that is this one here. Now the mole cancel out, and now we have to deal with the liter. Do we have liters anywhere? Yes, we have the liters in here, and we can write this 10 times 10 to the minus 3 liter. And again, we see that the liters cancel out. So we have 250 grams times 2 times 10 to the minus 3 times 10 times 10 to the minus 3. And if we put that in the calculator, we get 0.005 gram, which of course would be the same as 1, 2, 3, 5 milligram. In this question, we are asked about the molarity of a 0.1% solution. So what we are looking for here is the unit mole per liter. That is the definition of molarity. So that should be the unit that we are getting. Now, do we have anywhere the unit mole that we are looking for? Yes, it is here, because we can write 68 kilodalton as, we can write this as 68,000 gram per mole. So let's write it so that that mole is on top of our fraction line. We have mole divided by 68,000 gram. So the mole is okay, but now we have to deal with this gram. Do we have grams anywhere? Yes, we know that in 1% solution, this means 1 gram per 100 milliliter of a solution, or we can write this as 1 gram over 0.1 liter. Now we write this into our fraction so that the gram is on top, because then it would cancel out. So let's see what we've got. We have 1 gram per 0.1 liter. And the grams cancel out, and what we are left with is mole per liter here. And that is exactly what we want. So what we have got left is 1 over 68,000 times 0.1, and the unit would be mole per liter. So we get, if we put that in the calculator, 1.47 times 10 to the minus 4 mole per liter, or molar. We can write this like that, or we can also multiply it by 1,000, then we would get it in millimolar, so that would be 0.147 millimolar. In this question, we are asked to find the volume of water that we need to dissolve these 10 milligrams of the substance to give us a 5 millimolar solution. So what we are looking for is the unit of the water, so that would be liter. Now, do we have anywhere the unit liter involved? Yes, we have this in this 5 millimolar, because we can write this as, so 5 millimolar, that of course is the same as 5 times 10 to the minus 3 mole per liter. Now we write it so that our liter is on top, so liter divided by 5 times 10 to the minus 3 mole. Now we have the unit liter, but we want to get rid of the mole. Do we have mole anywhere? Yes, of course. We have this here, 200 grams per mole, and we write it so that the mole is now on top and it cancels out. So we have mole divided by 200 grams. So our mole cancels out, and we just have to deal with the grams. Do we have the unit of gram anyway? Yes, that's our 10 milligrams that we are looking at. So that would be 10 times 10 to the minus 3 grams. That's 10 milligrams, and we see it cancels out, and all we have left is the unit liter. So that gives us 10 times 10 to the minus 3 liter divided by 5 times 10 to the minus 3 times 200. Now that cancels out against that. So we have 10 over 1000. The unit is liter, and that would be 100th of a liter, and that would be the same as 10 milliliter. Now in this question we are looking for the concentration of a solution. So we are looking for the unit of mole per liter. Now, do we have moles anywhere? The unit mole? Yes, we have it in here. So we write this so that the moles are on top. We have mole divided by 500 grams. So the moles are all right, but we want to get rid of the grams here. Do we have any grams anywhere? Yes, we have. We know that we have 20 times 10 to the minus 3 grams. That's our milligrams in 200 milliliter of water. So that would be 200 times 10 to the minus 3 liter. Now the grams cancels out, and miraculously we have mole per liter left. And what is left is really 20 times 10 to the minus 3 mole divided by 500 times 200 times 10 to the minus 3 liter. Now the 10 to the minus 3 cancels out. And we get, if we put that in the calculator, we get 0.2 millimole per liter. In this question we are asked to make up a stock solution, and we can use the equation C1V1 equals C2V2, or we can use the shortcut and we say man goes into the pharmacy with a prescription, and on the first prescription it says we want to have 10 milliliter of a 2.5 millimolar solution. That is what we want. And the pharmacist says, sorry, we only have a 50 millimolar solution. That is what we have. And now we already have our equation, because all we have is 10 milliliter times 2.5 millimolar. So that gives us, we see that the millimolar cancels out, so that gives us 25 milliliter divided by 50, and that gives us 0.5 milliliter, and that's the volume of our stock solution that we need to make up these 10 milliliter of a 2.5 millimolar solution.